Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, I am going to cover the topic variation of parameters. So, to solve this differential equation of the type d square y by dx square plus p into dy by dx plus q into y is equal to r. Any equation of this type to solve by method of variation of parameters, let us see the procedure. You compare this, here this can be written as d square y by dx square plus y is equal to cosecant x. So compare these two and write down the values of p, q, r. So here p is equal to 1, dy by dx term is not there, so p is equal to 0, q equal to 1, and this r is the right side term which is given as cosecant x. So for this, first let us write down the auxiliary equation which is given by m square plus 1 into y, m square plus 1 equal to 0. So m square equal to minus 1, so we get m equal to plus or minus I. So if the complex roots alpha is 0, beta is 1, so we get yc equal to c1 cos x plus c2 sin x. So this cos x, let it be u, c2 coefficient, let it be v. So what is the particular integral yp formula? au plus bv, where u and v are functions of x. U is given by cos x, v is given by sin x. Now what is the formula for a and b? Where a is given by minus vr dx by w and b is given by ur dx by w. Find the values of capital A and B and substitute in this equation, we get the particular integral. First let us find A and B values. Here what is w? uv dash minus vu dash. So here u dash is minus sin x, v dash is cos x. So uv dash cos x into cos x, cos square x, minus sin x into minus sin x, sin square x, that is 1. Now a is equal to minus integral vr dx. V means what? Sin x. R means cosecant x. Wronskian is 1. So this w is called Wronskian, right? So minus integral sin x, cosecant is 1 by sin, so these two are cancelled, 1 dx, that is minus x. So we get a value as minus x. This we get a value. Now let us find b value. So b is equal to, the formula is integral ur dx by w. U means what? Cos x. R means cosecant x. W is 1 dx. So this can be written as integral cos x into cosecant means 1 by sin dx. So cos x by sin x is cot x. So integration of cot x dx, that is log mod sin x. So we got b value. Therefore let us write down the particular integral, a into u plus b into v. What is a value? Minus x. So minus x into u means cos x plus b means log mod sin x into v. V is sin x. This is particular integral. Therefore general solution is y is equal to yc plus yp. So add the complementary function and particular integral. Let us solve one more problem. This is in the form of f of d into y is equal to tan ax. So auxiliary equation is f of m equal to 0. So this is m square plus a square equal to 0. So m is m square equal to minus a square. So we get complex roots plus or minus ai, isn't it? So what is the formula? How will you write the complementary function? If the roots are complex roots, e power alpha x, alpha is 0 here. So c1 cos ax plus c2 sin ax. Here c1 coefficient let us take u, c2 coefficient let us take v. U equal to cos ax, v equal to sin ax. What is u dash? Minus a sin ax. And what is v dash? Derivative of sin ax is a cos ax. So let us find the Wronskian, which is given by u v dash minus v u dash or u dash v. So cos x into a cos ax, that is a cos square ax minus v into u dash, that is a sin square ax. So if you take a common, we get cos square ax plus sin square ax is 1. So Wronskian value is a. Now what is the particular integral yp? A into u plus b into v, right? So what is a here? Minus integral vr by w dx. Minus integral v means what? Sin ax. R means the right side term, which is tan ax, by Wronskian is w dx. So this can be written as minus integration of sin ax, this 1 by a, write it outside. Tan x means sin ax by cos ax. So minus 1 by a integration of sin ax into sin ax is sin square ax by cos ax dx. But this sin square ax can be written as minus 1 by a into integration of 1 minus cos square ax by, what is this, cos ax dx. So let us split this. Minus 1 by a into 1 by cos ax, integration of 1 by cos ax dx, minus integration of cos square ax by cos ax dx. So this can be written as minus 1 by a into 1 by cos is secant ax minus 1 cos get cancelled. So integration of cos ax dx. So this can be written as minus 1 by a into integration of secant ax is 1 by a log mod secant ax plus tan ax, right? Minus integration of cos ax is sin ax divided by a. We got a value. So a is equal to minus 1 by a square log mod secant ax plus tan ax plus 1 by a square into sin ax. So we got capital A value. Now let us find, we got this, we have to find b value. So b is equal to integral of u r dx by W. What is U here? Cos AX. What is R? Tan AX. So 1 by A into integral of tan AX is sin by cos. So we write this is cos AX into sin AX by cos AX dx. So cos AX cancel. So 1 by A into what is integration of sin AX? Minus cos AX by A. So B value we get it as minus 1 by A square into cos AX. This is B. So we got A and B values. Substitute A, B values in equation 2. We get YP. So YP is equal to A into U plus B into V. So what is A here? Minus 1 by A square log mod secant AX plus tan AX plus 1 by A square into what is A value into sin AX. Plus B into V. What is B? Minus 1 by A square cos AX. Minus 1 by A square cos AX. This is only YP. Therefore, general solution is given by Y is equal to YC plus YP. Add the complementary function and particular integral together, we get the general solution. This is how we find the general solution for method of variation of parameters. Thank you.